Hi guys, welcome back to Anjali's Math Test. In today's video, we will be continuing with rational numbers once again. And today's topic is representation of rational numbers on a number line. Now, let's look at the representation of natural numbers on a number line. So our number line starts at 1 and it goes all the way up to infinity. Now, similarly, let's look at what whole numbers look like on a number line. In case of whole numbers, the number line starts at 0 and goes to 1, 2, 3, 4, all the way to infinity. And now let's look at what integers look like. In this case, the line extends both ways, negative infinity and infinity. And we have 0, 1, 2, 3, so on and so forth, till positive infinity. And on the other side of 0, we have -1, -2, -3, so on and so forth, till minus infinity. Now, let's look at rational numbers. Again, it goes both ways, from negative infinity to positive infinity. And now let's see what some of the numbers might look like. So 0, half, 1, -1/2, -1. Again, all this goes all the way to infinity. So tell me what this number would be on the number line for rational numbers. So this is 0, this is 1/3. What will this be that this is 1 now? What number lies between 1/3 and 1? It is 2/3, because 3/3 equals 1. Now let's look at how to represent 4/3, 5/3, 6/3, or 7/3 on a number line. Now let's first draw our number line. And now we have 0/3, 1/3, 2/3, 3/3, which is 1. Then 4/3, 5/3, then 6/3, which is 2. Then 7/3, 8/3, 9/3, which is 3. So we see that 4/3 is right here, 5/3 is right here, and 7/3 is right here. Now, similarly, let us look at how do you represent 1/8 on a number line. We can divide the number line into 8 equal parts, like so. 0, 4, 5, 6, 7, 8. And now we can use 1/8 as the name of the first point of this division, and 2/8 as the name of the second point of this division, and 3/8 as the name of the third point of division, and so on. So this will be 4/8, 5/8, 6/8, 7/8, and 8/8, which is 1. Therefore, this is what our number line ends up looking like, and this is 1/8. Okay, so now what do we see? We see that any rational number can be represented on a number line. Now let's look at the rational number p/q. For any rational number p/q, where p and q are integers and q not equal to 0, the number below the bar is called the denominator, and the number above the bar is called the numerator. What is a denominator? What does a denominator tell us? It tells us the number of equal parts into which the first unit has been divided. And now what does the numerator tells us? The numerator tells us how many of these parts are considered. Therefore, for a rational number such as 5 by 8 means 5 of 8 equal parts on the right of 0 on a number line. And similarly, the rational number minus 11 over 9. What does this mean? It means 11 markings of distance 1 over 9 to the left of 0 on the number line. And minus 11 over 9 is the 11th marking on that number line. Again, to the left of 0. Now, let's look at representation of 5 over 8. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. Again, 8 equal parts, 5 of 8 equal parts on the right of 0. So we did that, and now this is 1 over 8, 2 over 8, 3 over 8, 4 over 8, 5 over 8, 6 over 8, and 7 over 8. So where is 5 over 8? Here is 5 over 8. And now let's look at the representation of minus 11 over 9. Again, it is to the left of 0. And 11 markings of distance 1 by 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is just an extra marking I have there. But now we start to mark these, and it'll be minus 1 over 9, minus 2 over 9, minus 3 over 9, minus 4 over 9, minus 5 over 9, minus 6 over 9, minus 7 over 9, minus 8 over 9, minus 9 over 9, which is minus 1, minus 10 over 9, and minus 11 over 9. This is where minus 11 over 9 is. Now let's look at a few examples together. In this number line, 0 over 5, 2 over 5, 3 over 5, 6 over 5, 7 over 5, 10 over 5, 11 over 5, and 12 over 5. We have to determine what are the values of A, B, C, D, and E. We see that the value of A will be 0 over 5 and 1 over 5. The value, similarly, value of B will be 4 over 5. Value of C will be 5 over 5, which is also 1. Value of D, since it's after 7 over 5, it'll be 8 over 5. And value of E, the very next one, will be 9 over 5. Now let's look at another example together. Let's look at the negative ones this time. Okay, we have to find the value of F, G, H, I, and J. So in this case, F will be 0 over 6 minus 1 over 6. It'll be minus 2 over 6. Similarly, G will be, again, we start counting again, minus 3 over 6, minus 4 over 6. It'll be minus 5 over 6. And H will be minus 6 over 6, which is 1, and H will be minus 7 over 6. I will be the very next one, minus 8 over 6, and J will be g is after minus 10 over 6, it'll be minus 11 over 6. Now let's talk about rational numbers between two rational numbers. Now before we dive into rational numbers between two rational numbers, can you tell how many natural numbers are between 1 and 4? It's 2 and 3. And now, how many natural numbers are between 8 and 10? Just 9. And now, how many natural numbers between 10 and 11? None. 0. There are none. Now, let's look at the integers. List all the integers between minus 5 and 3. It'll be minus 4, minus 3, minus 2, minus 1, 0, 1, and 2. Now, list all of them, or list all the integers between minus 1 and 1. It's just 0. And now, how many integers are there? How many integers are there between minus 9 and minus 10? Again, none. 0. No integers between minus 9 and minus 10. Now, we see that we always find a definite number of natural numbers between two natural numbers, and we see a definite number of integers between two integers. But now, how many rational numbers are there between 3 over 10 and 7 over 10? You may want to say that there are only 3, which is 4 over 10, 5 over 10, and 6 over 10, right? But now I can also write 3 over 10 as 30 over 100, and similarly I can write 7 over 10 as 70 over 100. Now how many rational numbers are there between 30 over 100 and 70 over 100? There's 31 over 100, there's 32 over 100, so on and so forth, 68 over 100, 69 over 100, and then there's 70 over 100, right? This is more than just 3, right? That's 39 rational numbers between 30 over 100 and 70 over 100 right now, which means those are 39 rational numbers between 3 over 10 and 7 over 10 when written as 30 over 100 and 70 over 100. But now, what if I write 3 over 10 as 300 over 1,000 and 7 over 10 as 700 over 1,000? How many rational numbers are there now between the two rational numbers? Again, there's 301 over 1,000, 302 over 1,000, so on and so forth, 698 over 1,000, 699 over 1,000, right? It's 399 rational numbers between those two rational numbers. And now, similarly, if we keep going on and we represent 3 over 10 as 3,000 over 10,000 and 7 over 10 as 7,000 over 10,000, we will find even more rational numbers between those two rational numbers. And if we really see the pattern here, we will have 3,999 rational numbers between technically 3 over 10 and 7 over 10. Therefore, we can keep inserting numbers like this between 3 over 10 and 7 over 10. Therefore, unlike natural numbers and integers, rational numbers between two rational numbers are not definitive. Now let's look at the numbers between minus 1 over 10 and 3 over 10. Obviously, again, you're tempted to say 0 over 10, 1 over 10, and 2 over 10. But if we, again, write 1 minus 1 over 10 as minus 10,000 over 100,000, and 3 over 10 as 30,000 over 100,000, then we see way more rational numbers between minus 1 over 10 and 3 over 10, right? Therefore, we can say that there are countless rational numbers between two rational numbers. Now, let's solve a few questions together. Write 3 rational numbers between minus 2 and 0. Minus 2 can be written as minus 20 over 10, right? And 0 can be written as 0 over 10. Therefore, we see between minus 20 over 10 and 0 over 10, we have minus 19 over 10, minus 18 over 10, so on and so forth till minus 1 over 10. And you can pick any 3 rational numbers from there. Let's say we pick minus 19 over 10, minus 18 over 10, and minus 17 over 10. Now, second one is find 10 rational numbers between minus 5 over 6 and 5 over 8. Now, we can write minus 5 over 6 as follows. We can multiply both sides by the denominator and the numerator by 4. And this brings us minus 20 over 24. And similarly, we can write 5 over 8 as, we can multiply this by 3, will be 15 over 24. Now we see that the denominator is same for both of them. And now, just to find 10 rational numbers between minus 5 over 6 and 5 over 8, we can just find 10 rational numbers between minus 20 over 24 and 15 over 24, since they have a common denominator. So the rational numbers between minus 20 over 24 and 15 over 24 are minus 19 over 24, minus 18 over 24, minus 17 over 24, minus 16 over 24, minus 15 over 24, minus 14 over 24, so on and so forth, till 11 over 24, 12 over 24, 13 over 24, 14 over 24. So we can pick any 10 rational numbers and they will fall between minus 5 over 6 and 5 over 8. Let's say we pick all these ones that I have just listed here, because these are 10 of those. Now let's solve the third question, which is find rational numbers between 1 over 4 and 1 over 2. We know we can write 1 over 4 as, to make the denominators common, we can write it as 2 over 8. And we can write 1 over 2 as 4 over 8. So now they just asked find rational number between 1 over 4 and 1 over 2. We see that it is 3 over 8. Therefore, the rational number between 1 over 4 and 1 over 2 is 3 over 8. Now let me show you another way of finding rational numbers between two rational numbers. The other way looks something like this. Now, if we were to use the same question, find rational numbers between 1 over 4 and 1 over 2, we could solve it as follows. We can say 1 over 4 plus 1 over 2 divided by 2, which equals 1 plus 2 over 4 divided by 2, which equals 3 over 4 divided by 2, which is also 3 over 8. Therefore, we can find the midpoint of A and B, which is C, represented by 1 over 4 plus 1 over 2 divided by 2 equals 3 over 8. We see that 1 over 4 is less than 3 over 8, less than 1 over 2. Therefore, if A and B are rational numbers, then A plus B over 2 is a rational number between A and B, such as A less than A plus B over 2 less than B. Now let's solve some questions using this concept of midpoint. Example, find 3 rational numbers between 1 over 4 and 1 over 2. We know that 1 over 4 less than 3 over 8 less than 1 over 2. So we know of a rational number between 1 over 4 and 1 over 2, which is 3 over 8. Now we can find the midpoint of 1 over 4 and 3 over 8, and we can find the midpoint of 3 over 8 and 1 over 2. Now let's first find the midpoint of 1 over 4 and 3 over 8, which will be, using the method we just learned, 1 over 4 plus 3 over 8 divided by 2, which turns out to be 5 over 8 divided by 2, which is 5 over 16. And between 3 over 8 and 1 over 2, we have 3 over 8 plus 1 over 2 divided by 2, which is 3 plus 4 over 8 divided by 2 equals 7 over 16. Therefore, we have now found 3 rational numbers between 1 over 4 and 1 over 2, which can be listed as 3 over 8, 5 over 16, and 7 over 16. These 3 rational numbers fall between 1 over 4 and 1 over 2. Now let's solve a few more questions together just to get those concepts solidified. First one, represent 7 over 4 on the number line. Okay, so 0, 1 over 4, 2 over 4, 3 over 4, 4 over 4, which is 1, 5 over 4, 6 over 4, and 7 over 4 is right here. And now second, represent minus 2 over 11, minus 5 over 11, and minus 9 over 11 on the number line. Okay, we draw the number line, and it's to the left of 0, since it's negative. See, minus 1 over 11, minus 2 over 11, minus 3 over 11, minus 4 over 11, minus 5 over 11, minus 6 over 11, minus 7 over 11, minus 8 over 11, minus 9 over 11, minus 10 over 11, minus 11 over 11, which is minus 1. So minus 2 over 11 is right here, minus 5 over 11 is right here, and minus 9 over 11 is right there. Now let's look at the next question. 5 rational numbers smaller than 2. Minus 1, minus half, 0, 1, 1/2. There are many other before 2 comes. So these are some of the rational numbers that we have gathered that are smaller than 2. Now moving on. 5 rational numbers between a 2 over 3 and 4 over 5. We can write 2 over 3 as 2 times 20 over 3 times 20, which is 40 over 60. And similarly, we can write 4 over 5 as 48 over 60. Now we see they have same denominator, and now it's easy to find 5 rational numbers between 40 over 60 and 48 over 60. So we can list 5, 41 over 60, 42 over 60, 43 over 60, 44 over 60, 45 over 60, 46 over 60, 47 over 60. We listed all of them since there were not that many between them, but 5 can be just these many of them. And now part B of the same question, which is find 5 rational numbers between, this time, minus 3 over 2 and 5 over 3. Now again, to make the denominator the same, we can write minus 3 over 2 as minus 3 times 3 over 2 minus 9 over 6, and we can write 5 over 3 as 10 over 6. Now again, we can find 5 rational numbers between minus 9 over 6 and 10 over 6. There are many, but I'll just list 5 of them, which will be minus 8 over 6, minus 7 over 6, minus 6 over 6, which is minus 1, minus 5 over 6, and let's say 9 over 6. So let's say these are the 5 that I listed, but there are many between minus 5 over 6 and 9 over 6 as well. Now, next question. Find 5 rational numbers greater than minus 2. Pretty easy. We know minus 1 is greater than minus 2, minus half is, 0 is, half is, and 1 is. So 5 rational numbers greater than minus 2 are minus 1, minus 1 half, 0, 1 half, and 1. That was really easy. Now, let's do the last question for now, which is find 10 rational numbers between 3 over 5 and 3 over 4. We know that we can write 3 over 5 as 96 over 160, and we can write 3 over 4 as which is 120 over 160. Now we see that the denominator is the same. Therefore, we can find 10 rational numbers between 96 over 160 and 120 over 160. I'll list some of them. Some of them are 97 over 160, 98 over 160, 99 over 160, 100 over 160, 101 over 160, 102 over 160, 103 over 160, 104 over 160, 105 over 160, so on and so forth, 118 over 160, and 119 over 160. So you can pick 10 rational numbers between those two rational numbers, and there you have 10 rational numbers between 3 over 5 and 3 over 4. So you can pick any 10 rational numbers between 96 over 160 and 120 over 160, and those will be the rational numbers between 3 over 5 and 3 over 4. So this brings us to the end of our video. If you guys do like my video, please do not forget to like and share this video, leave a comment down below. Also, subscribe to my channel and hit the bell icon so that you never miss a video ever again. If you guys do have any special requests on some questions or other math topics, please leave them in the comments down below and I will get back to you on those as well. Bye for now.